Society on the theme Education 4.0 for Safe Sustainable Societies. We appreciate and applaud everyone, our panelists and the participant for the zeal to share and passion to learn with Samurja. Samurja, the sum of creative energies. Here is a small video about Samurja.
Samurja Educational Society, established in the year 1991, has completed its gratifying journey of 3 decades. The society was conceptualized with the objective of educating children and preparing them to be morally upright and vocationally independent. Ever since its inception, the society has continued to take tiny steps forward, redesigning the educational fabric in all possible ways through various educational activities, besides conducting social outreach programs like the Girl Next Door and the Charity War. Samurja is constantly striving to bring together some of the most ignited minds in the field of education to introduce change in the educational fabric of the nation by providing educational vision, empowering educators, inspiring learners, and elevating various organizations through training sessions, panel discussions, talk shows, conferences, and symposiums. The Society has also conceptualized and published periodicals and magazines for students and teachers. Samurja continues to explore new domains, trends, and landscapes to enrich the educators across the country by equipping them to resolve the academic challenges in their classroom to make teaching and learning more joyous and engaging. It also helps educators realize their vision and collaborate with national and international educators to have sustainable societies and a happy nation, thus redefining the paradigms of Indian education. Jai Hind, Namaskar.
In this series of Experion, our last session was storytelling, a pedagogical approach, sensitized us that stories have great impact on our lives. I tried analyzing it, whether it is possible in all subjects like mathematics, chemistry, physics. I reflected and remembered 2 stories taught by my teachers, which I would like to share. Once upon a time, a young boy who joined medical college as his mother wanted him to be a doctor. After 4 years, he left his course without a degree, came to his town and started tutoring mathematics. Quite often, he will continuously gaze at sky for long. After a gap of 5 years, he joined a college to teach geometry, mathematics, and sometimes astronomy. Simple concepts about sun, star, and all the planets that revolve around the earth. This was the model given by Aristotle for more than 1,000 years before that time. He also learned a few more theories given by Nicholas Copernicus. And the name of the boy was Galileo, who invented the first telescope and then improvised it in many versions. Later, he was known as the father of modern physics, the father of astronomy, and Albert Einstein called him as the father of modern science. Then he learned other lessons. We realized that the father of Indian physics, Dr. Homi Jahangir Bhabha, and many other like C.V. Raman and Vikram Sarabhai. Another story was about a kingdom where a king gave a brick of gold to the goldsmith to make a crown for him. The goldsmith made a beautiful crown, but the king felt that he has cheated him and not used all the gold. He called his scientist to the court and ordered him to find out the solution, whether the goldsmith has cheated him without decasting the crown. King gave him 7 days time to find out the answer, else he would be beheaded. The scientist tried hard to think, experimented in his lab, but failed to get the answer. On the seventh day, he was sad, thinking about his last day of life. He went to take bath and sat in the tub in his bathroom, which was filled with water. That moment, the moment he entered the tub, water overflowed and spilled. He became so excited and happy as he got the answer. He started running on the streets shouting, Eureka, Eureka. People on the street were amused and laughing as the man was not wearing anything. He was nude. In the excitement, he did not wear clothes. I remember the whole class started laughing when my teacher was sharing this. He was Archimedes, and till date, I remember the Archimedes principle. When anything is immersed in fluid fully or partially, it displaces the fluid equal to its weight. And then we learn buoyancy and hydrostatic force. NEP 2020 has envisaged many other things besides pedagogical approaches. Since we are talking about physics, let's learn more about the physics in our talk show, Experion Physics. We have with us Mr. Anil Sharma, Principal, Birla Vidya School, Nainital. Sir is a national awardee. I request Anil sir to kindly extend the verbal greeting. Anil sir.
Good afternoon, Mukta madam, Monica madam, Dr. Hasija, Dr. Pandey, and Dr. Chaudhary. At the outset, I would like to thank Samurja to provide me a platform to interact with the people, those who are in this noble profession of teaching. And Dr. Hasija and Madam, they told me that, if you can conduct a session on physics, teaching of physics mainly, starting with the new education policy. If we talk about the new education policy,
I would like to welcome you formally. I
No,
request
ma'am,
Monica ma'am. Yes, welcome, sir. Welcome to the
thank
show.
you. Thank you.
I request Monica ma'am to welcome our guest with a musical note and introduce him, please. We also have with us our mentor and a charismatic leader, Dr. Rajesh Hasija, Director in the Prastha Group of Schools, who has really designed this talk show and is a leader par excellence. We would like to welcome Dr. Hasija.
Good afternoon, everyone, and thank you, Dr. Mukta. I'm really proud of this talk show, the way you are.
So you're muted.
Good afternoon, Dr. Mukta. I said, I'm so fortunate to be part of this talk show The way you are empowering people, it's hugely appreciable. Welcome, Anil sir.
Thank you, sir. Thank you.
Thank you. Thank you so much. Another mentor, Dr. Ashok Pandey, who is not with us. He is simultaneously conducting another session. We are really proud of our mentors. Dr. Hasija also, he has to take another session simultaneously. Thank you so much for sparing the time, Dr. Hasija. Without further delay, I would like to request Anil sir to please share with us the changes which NEP has suggested for different subjects, especially for physics, and how the teachers, they can train the students in a way so that NEP objective is, you know, absorbed. Over to Anil sir, please.
Thank you, ma'am. Madam has already shared this idea that NEP has made so many changes, and there is a paradigm shift in the school education, not only in the subject of physics, but overall in the school education. And I'll quickly go through the main points of NEP, which all of us we know. The main change in the structure of the school education that the NEP has brought in is that it has included the elementary education or the pre-primary education, and the structure has now changed from 10 plus 2 to 5 plus 3 plus 3 plus 4, where the these 5 years, they takes care of 3 years of preschooling, and then 2 years, that is classes 1 and 2. Then 3 stands for classes 3, 4, and 5. So 5 plus 3, it completes the primary education. And then the middle school we talk about, it is 6, 7, and 8, 3 years of schooling. And the last bracket is of 4 years. And till now, we were saying, class 9 and 10 as secondary school or secondary classes, and 11 and 12, we were saying senior secondary, but now they have clubbed it into 4 years bracket, and they would be calling it the secondary school education. The next point, which is very, very important, that there is no hard separation between the different subjects. There are no watertight compartments. Now, a student of who is a science student can also opt for history, can also opt for design thinking, can also opt for psychology, and so on and so forth. Then they have coined this idea of literacy and numeracy. Literacy and numeracy, these are very, very important pillars of the school education. And in the NEP, they are saying that the assessment of literacy and numeracy, there will be an assessment test at the end of classes 3, 5, and 8. And I'm sure that, it will definitely add value to the school education. Teaching of the different subjects in the mother tongue are mandatory. They have made up to class 5 and if possible up to class 8, because the impact of the mother tongue on the overall personality of the child is huge, and that is why they have emphasized on the teaching of the different subjects up to class 5 at least in the mother tongue. Use of information technology in the transaction of curriculum, that is in the entire teaching learning process. You know that during the pandemic time, we have moved from offline classes to online classes, and it would have been possible only with the use of the information technology in the teaching learning process. And this is the future of the school education also, because we have to have, this hybrid mode. And we teachers, we head of the institutions, we have to be mentally prepared, and we have to add on to the infrastructure so that as and when it is required, we can switch over from offline to online and vice versa. Then introduction of the vocational or the skill subjects from class 6th onwards. As all of us know that the government is talking about the Skill India, and in continuation of that, they have introduced the vocational or the skill subjects from 6th onwards. And the concept of the bagless schools for 12 days in a year, in the academic year. Now the children from classes 6 to 8, they would be coming to the schools wherever, these skill subjects are being offered. And then the outcome based education they are talking about, that is whatever instructional objectives were there, whatever expected learning outcomes were there, these should be evident when the child has completed a particular class or a particular portion of the subject. So these are the main points where the government has emphasized, and gradually, of course, in the school education, NEP will be implemented, and in view of Corona, they have actually preponed the implementation of NEP, because if you have a look at the calendar, then in 21-22, two things were to happen. That is, one was the preparation of the national curriculum of framework for the early childhood, and the second one was for the main school. So I'm sure that the government has taken a very wise decision, and we teachers have to implement it on ground. I would request Monica Madam if she can share a slide. So these are the 8 key principles of the national education policy, starting from number 1, respect for diversity and local context to be reflected in our curriculum, pedagogy, and policy. Then equity and inclusion to become the cornerstones of the education decisions. Then community participation, uplifting, philanthropic, and private community and participation. Then the fourth one is the use of technology that we have already discussed. Then number 5 is emphasize conceptual understanding, learning for exams with no rote learning. The main shifting will be from the rote learning to the concept understanding. And then unique capabilities, recognizing and then tapping them in each students. Critical thinking and creativity to boost the logical decision making and innovation. And the last but not the least is continuous review built on the sustained research and regular assessment by educational experts. So these are the 8 main key points, key principles of the national education policy. Monica ma'am, the next one can be. This is the picturized version of the India's NEP, the ideal output of the school education policy. They are saying that, better soft skill, the child should be better equipped as far as the soft skills are concerned, tech skills, humane values, and competencies. They are talking about the competencies of 21st centuries. And then respect, unity in diversity, Then good grasp of mother tongue, as I have already uh, touched upon this point, that the teaching of the different subjects up to primary level in the mother tongue, it has been recommended. Fun and activity based learning, age appropriate activities are to be conducted in the school while transacting the curriculum of the different subjects. Simple curriculum, lesser number of books. So the lighter bags concept, they are going to, and in continuation of this only, they have given this idea of bagless schools for 12 days in one session. No exam fear, no rote learning, occasional training received, and it is highly adaptive. Better knowledge of India, its heritage, culture, and heroes, then knows more than one Indian language, knows at least one foreign language. People were apprehensive when this NEP draft was prepared, that this NEP will remove all the foreign languages. But we are very happy and we are thankful, grateful to the committee that even the foreign languages are included in this, and better all round health. Health, when we say, it is not only the physical health, we are also talking about the mental health of the students. And if we talk about what the physics is, physics, all of us know that it is a very, very important branch of science. Some people say that, the physics is the mother of all sciences, and all other sciences came from physics only. I would request Monica Madam to please play a short video, or the scientific methods are involved out here. And Monica Madam, can you go back? Yes. So any science subject which is taught, it would involve, these steps. The first step would be observe, that is, the child is making observation. This is a very, very important point and a vital point as far as the teaching of any science subject is concerned. Then the question comes to the mind of the child, that ask a question or identify a problem based on the observation. And then the child goes in for research, that is, search for the existing answers or the solutions, whatever facts and figures are available regarding that problem, available through the different sources the child would be researching. And then the child prepares a hypothesis, that is, formulation of the hypothesis has taken place in this step of the scientific method. And then the child goes in for the experiment, design and perform an experiment, and then test the hypothesis, whatever hypothesis in the fourth step the child has made. After experimenting, the child would compare the hypothetical results and the experimental results, and based on that, child will accept or reject the hypothesis. And then finally, the child draws a conclusion, that is, makes conclusion based on the hypothesis, and then finally submit a report and share your results. So these are the important steps of the scientific methods, and in the teaching of all science subjects, these are the common steps which are used by we all teachers. Particularly moving on to physics, I would request Monica Madam to please play the video. Thank you.
What makes physics so cool? To me, physics is awesome and interesting because it asks the one question that no other science does: how? Physics looks at how things happen, the reason things happen, and explains it. No other science does this. Chemistry deals with the result of things happening, while biology deals with the why things can happen, but physics deals with the how things happen. take, for instance, a moving car. A biologist would look at a moving car and wonder, why is it able to move? He would probably ask himself, what is it about the way those parts work together that make it go forward? Why is it able to happen? A physicist, on the other hand, sees a moving car and wonders, how can the car move? What is providing a forward motion? How are the wheels even able to turn? And on the other end of the spectrum, we have a chemist who would probably see a moving car and wonder what would happen if we threw sulfuric acid into the tank. But what is physics? Well, the ultimate goal of physics is to understand the universe around us. This ranges from tiny, intermolecular particles to huge things like entire solar systems. Physics argues that there must exist fundamental rules that govern the how of everything around us, and it is the physicist's job to find out what those rules are and apply formulas to them. It is really fascinating how much we already know, yet mind-boggling how much we don't. Such simple mechanics, such as Newton's famous force equals mass times acceleration equation, can help scientists understand the basic motion of nearly anything. So, I'm here to teach you guys these principles too. That answers what the basic goal of physics is, but doesn't answer what we actually do in physics. Well, in its simplest form, physics is applied mathematics. Now, you've probably heard the term applied something before, but I'm not sure you really know what that means. To answer that, think about a toolbox. Essentially, all of the math you learned since elementary school are tools that were put into this toolbox. We all start off with an empty toolbox, and as we get older and learn more complicated math, we sort of buy and learn how to use new tools. By the time we hit physics, we have a good set of tools that we're very familiar with using, but we never really used them before. See, mathematics is a class that teaches you what the tools are and refines your ability to use them, but you never truly use them. So what's the purpose of knowing these math concepts? Well, what's the purpose of owning and learning how to use tools? To build things. In physics, we take the tools that we learned in our math classes and apply them to real-world problems. For example, if we want to find out how high a ball that was thrown upwards will travel, we can use the algebra that we learned nearly 2 years ago to figure it out. All physics really is just applying, or should I say finally using, all of the tools you've accumulated throughout your education to figure out the way the world behaves. Now, physics has a bad reputation as being one of the hardest sciences you can take in high school. This can be true, but I believe every concept can be broken down and simplified. That's why I'm here to teach you guys the wonders of physics. From the fundamental Newtonian equations to the famous E equals mc squared, together we will embark on a journey to better understand the world around us. So, take a step back and prepare to see the awesomeness that is the world of physics.
Thank you, Monica. So we have seen in this video that how mathematics is important to study physics or to teach physics. And in the process, we physics teachers, we make physics very, very difficult. As it is, you know, the physics is considered to be a difficult subject. But I think to an extent, the credit goes to we physics teachers also to make it more difficult. And from my teaching experience, I will take few examples wherein, you know, these I came across, you know, students where they said that, sir, what you are teaching, first you have to tell us that why should we study this? Because as per the definition of physics, physics is the study of nature and the natural phenomena. And when I talk to the students and my teachers, I always say that so-called man is the most beautiful creation of the Lord Almighty. So all laws of physics are applicable to the human beings. And the teachers who are teaching physics, they would agree to this, that whether it is law of conservation of energy, whether it is law of conservation of linear momentum, all these laws are actually applicable to the human beings. And generally, we physics teachers make a statement that every system in this universe tends to have a state of minimum potential energy, and it is most suited sentence to the human being, because the moment you try and increase the potential energy of a human being, we become restless. So I would like to share that 5 things that we physics teachers uh, must remember while teaching this subject, which to me is very, very interesting. We only make a dry subject. People say that those who teach physics, they are dry people, but subject is not dry. We make it dry. To me, we must give time to the students to understand the problems. When we are young teachers, we try and solve the maximum numerical problems in the classroom situation. And when we come out of the classroom, we have a feeling of contention that we have solved these many problems. But my humble request to all the teachers that you please ask the students that how much questions have they understood. If they have understood the question, then only they will understand the answers and the solution to the problems. That is, we should allow them to work on their own. We dictate a question, a numerical problem or a conceptual problem, and we immediately start solving it on the blackboard or whiteboard. And we think that, we are on the top of the world. But if we swap our, locations, if we are the student and one of the students he is teaching in the classroom, how do you feel as a student if your teacher is only dictating you the question, is not allowing you to understand the problem and solving the problem only? So this is a very vital step, and the organize and simplify the problem for the students step by step. Whatever the data is given in the numerical problems, we must tell the student that what all is given. If a hint is required, if a tip is required, I think we teachers must give them the hint. We must give them enough time to solve that problem. At the most, it would be wrong. And even if it is wrong, heaven will not come down. We are always there to support these children. And whenever, I go to my class and teach, and not that, I'm still teaching and I have a structured timetable. In besides doing all this unproductive work that we do as principal, my co-teacher decides my syllabus, and when I go to the class, I always tell these students that if a person like me can teach physics, you are the next generation, you are much better than me, you can easily understand physics. Then moving on to the next point, that make them excited about the topic that you are going to teach them. It happens actually on the first day when you introduce a new topic. So they should be full of energy. You should like, suppose if we are teaching them the gravitation, give them some examples of the real life situation before you actually introduce the concept of gravitation. And when we are teaching them gravitation, very often, we physics teachers, we interchange the term, the gravitation and gravity. Unintentionally, in the process, we forget that what is gravitation, what is gravity. We make physics something the students, they care about, and they know that how important the physics is to them. Once they understand that how important is physics in their life, I'm sure that 50% problems are over. This is very, very important. And there are 10 more points I would like to discuss with the learning teachers, that whenever we are teaching a concept, we should try and narrate. Initially, Madam Mukta, she narrated 2 stories before starting the session. And we should try and narrate the history of the concept, any new concept that you're going to teach, with a story-like format. As far as possible, we should try and introduce the topic by way of storytelling, because it will be ice-breaking for the students also, and they would be more interested. Use humor whenever possible. Humor is very, very, because they say physics is dry subject. Physics teachers are dry. They are always with the frowning, faces, and they are only interested in the derivation concepts and numerical problems. Otherwise, they are not interested in anything else. So we should try and use humors, humor wherever it is possible. Then we define the concept. And after defining the concept, one very, very important point I would like to share with you all, and I hope you will agree with me. Whatever definition that we give, we expect that the same definition, same wording should be there in the examination. But I always tell my boys that the meaning should not change. You can frame your own sentences. Next one is introduce the students to the equation associated with the concept, wherever mathematical concepts are there. Then you tell them that, V is equals to U plus AT, or S is equals to UT plus half AT square. They explain to them that these are the symbols, these are the symbolic representations. This is the meaning of the different symbols that we are using in the equations. This is very, very important. If they miss...
There is a question, I'm sorry, I'm interrupting you, because the context is the same. One question is physics dependent on mathematics?
Well, madam, physics use application of mathematics is of course required in teaching of physics, because mathematical tools are there to solve the physical problems. Right? So they go hand in hand. Without mathematics, it is not possible to teach physics.
All right.
I'll give you examples also, Then you relate that concept, whatever concept you have coined, whatever concept you have introduced. We should try and relate that concept to the daily life. Daily life examples are very, very important. And then apply those concepts, and in the different situations, here the role of numerical problems comes in. Generally, people say, whenever, I teach a concept, the boys, they come to me, sir, my concepts are clear, but I'm finding it very difficult to solve the numerical problems. In my view, if you are finding difficult to solve a numerical problem, it means that somewhere your concepts are not clear. It's other way around. Then make sure that they understand the problem. I told you, even in the 5 points that I told beforehand, that we should try and give them enough time to understand that problem. Because if they understand the problem, definitely, they will try and solve the problem. And then allow the students to ask questions continuously. This is one thing that does not happen in classrooms, and particularly in physics classrooms. Please allow them to ask questions. At times, their questions are silly also, but doesn't matter. I'll give you examples. When I was doing my B.Ed, our professor was teaching that how to prepare a lesson plan on gravitation, and it was the teaching of physical science. And the gentleman, he dropped a sponge ball, and then he made a statement that every body in this universe attracts every other body with a force that is directly proportional to the product of their masses inversely proportional to the square of the distance between them. And then, when he dropped the ball, he asked the students, and one student answered that, sir, because the floor is attracting the ball towards it, and that is why the ball is coming down. His next question was that after striking the floor, the sponge ball, it is going back. So what is the reason? And one student, he stood up and then said, sir, because the ball is attracted by the roof, and that is why it is going up. So jokes apart, because just before that, he made a statement that every body in this universe attracts every other body. The child was not wrong. So we should try and be patient with the children. I know every time it is not possible, but we principals, we be patient with the teachers also, with the parents also, with the management also, with the students also. So we teachers, when we go to the classroom, we have to be patient. Then demonstrate the concept wherever possible, and preferably a visual demo would be better, because it will have a long-lasting impression on the mind of the child. So these are the things which I thought, I'll share with you. Now, moving on to the examples. When I say examples, let me share it with you that since many of you are associated with the NPSC, and we are also the member of NPSC, member of IPSC also. So I think all the physics teachers, they know about revered late Suraj Prakash ji. And when I was a young teacher, I happened to, interact with him. Not that I'm old now, but he always used to say, Anil, first go to the level of the child when you're teaching physics. And in the process, bring the child to your level. That is the level of the teacher. And these were the golden words of Suraj Prakash ji. And we really miss him, a real gem and an authority in physics.
I would like to share, sir, that Suraj Prakash sir was the president of Samurja Society at one moment. So we have, he is one of our mentors who has supported Samurja in a big way.
Exactly. Real gem and an authority in physics, right? I happened to work with Dr. Stalin Malhotra when I was working with the Delhi Public School Society. And at that time in DPS, they coined their new idea of having 2 subject experts in each subject for the society, Delhi Public School Society. And proudly, I can say that Dr. Stalin Malhotra and me, both of us, we were the resource person for Delhi Public School Society. Right. And I learned a lot from him. When I would share some examples that I came across while teaching different concepts of physics. We teachers, when teaching, we teach class 11th and introduce the mathematical tools. And we start with the trigonometrical ratios, differentiation and integrations. One fine day, one child stood up and said that, sir, let me tell you, I was sick and tired of these trigonometrical ratios in class 10th. And that is the reason that I have not opted for biology. Had I known that, again, these trigonometrical ratios will eat up my head in class 11th while teaching physics, I would not have opted for physics. He said, sir, whatever you teach, I will learn also. And I'll do very well. But you tell me that why should I study these trigonometrical ratios? And then I told him, I just gave him an example of tan theta. And I said that, son, we are in the hilly area. Right on the opposite of the lake, there is a cliff. And if you want to find out the height, either you have to go there. You may not have that long measuring tape to measure that cliff. Then I took him out, and then after my class, I gave him the sextant. And then I said, you can find out the height of these buildings, which otherwise very, very difficult to find out. And once the child was convinced, after that, there was no problem. Then while starting the differentiation, oh my goodness, we write d by dt of x square plus 2x plus 3. And my goodness, these children, sir, why are you doing all this? You please tell us there where it will be used. Then I told him that, when we come from Mall Road to our school, then there is a different, there is a definite slope on the roads. So differentiation decides actually that what should be the slope. Because, we mathematics teachers, they do talk about slope. We physics teacher don't talk about slopes. We are only interested in solving the problems that if the equation of the displacement is given, we have to find out the velocity, we have to find out the acceleration. We are not interested whether a child is understanding or not. We just tell them that if it is x to the power n, when you differentiate it with respect to x, so it will be nx to the power n minus 1. That's it. That ends there. Then in the gravitation, we We use the binomial theorem while driving the relation for the variation of G with height or altitude. We, at a particular step, we say that using the binomial expansion and neglecting the higher powers of h by r, the height to the radius, and child is completely lost. Because we are not interested in telling them that what is the expansion of binomial theorem. If we are able to tell them 1 minus x raised to the power n or 1 minus x raised to the power minus n, this will be the expansion of it. It might take 10 minutes. It might take 10 minutes, but if you have solved that binomial expansion, the children, they will not find it very, very difficult to understand the concept. And then finally, when we have derived that relation, GH is equals to G into 1 minus 2H by R. In numerical problems, sir, sometimes you use this formula directly. Sometimes you use the gravitational universal law of gravitation. Again, the child is confused. We have to tell them that where to use this formula directly, where not to use this formula directly. This is very, very important. Solid semiconductor devices, when we are teaching them the energy band theory, we teach them valence band, conduction band, and forbidden gap. Because see, you actually can't show them by that energy band theory. It is not visible that you can tell them that this is the valence band and this is the conduction band and then this is the forbidden gap. I tried a method and it has been successful. I tell them that the government has come up with a scheme that on one side, economically weaker sections, people, they would be allotted houses. Just opposite, the general people, those who are coming from the higher economic strata, they would be allotted houses. And in between, there is a passage. And when the electrons, they gain energy from valence band to conduction band. So I said this EWS section is valence band and the upper economy section is the conduction band. There are people in the EWS category, they work very, very hard. They earn a lot of money and gradually they move from one lane to the opposite lane. On the other hand, those who are from the higher economic strata, maybe their business is not doing well, so their income comes down and they are going to the opposite lane, that is EWS lane. But please remember one thing, that the person from EWS can go to the opposite lane and vice versa, but cannot build a house in the passage, on the passage, and that is the forbidden gap. And when I have told them this way, they don't forget, because they are able to correlate that what is EWS, lower energy level, conduction band, higher energy level. In between, there is a gap, and that is the forbidden gap. If you wish to have a function, you can put a tent temporarily there, but you cannot construct a house there. And then once they understand, then there is no problem. Then frequently we use these terms. then the children, they are generally confused. Sir, what is the difference between the shadow and image? Shadow and image. At times, in the flow, we say almost it is one and the same thing. But one is because of the presence of light, other is because of the absence of light. I mean, very, very minute concept, but very important concept for the child. Pressure and stress. They have same units, same dimensions, but still they are different. What is the basic difference between them? Teaching of rotational motion, people say it is the most difficult concept to be taught in the classroom. I have tried it with my class 11th, and I teach them with the help of doors and windows in the room. And then they understand the concept of line of action and axis of rotation very well. Even the torque, angular momentum, they understand very easily. So what I mean to say, these are my personal experiences that I have shared with you. We physics teachers should try and make physics interesting, make physics relatively easier to understand. Because psychologically, it is already registered in the mind of these children that physics is a very difficult subject. Right? And the last example I would like to quote here. I requested you all to use humor while teaching physics.
This is a question also asked by this is Arvind Kaur. Sir, please share experience where you have used humor to explain a concept.
Yeah, certainly. Because it is actually, the humor and physics generally, they are poles apart. But actually it has happened in the classroom that while teaching the electrical resistance, its unit is ohm, right? One child stands up and says, sir, what is the bigger unit of electrical resistance? So physics teacher says kilo ohm. And the child asks, sir, if it is even bigger, the physics teacher says that mega ohm. Child asks, sir, if it is even bigger, then the physics teacher says giga ohm. Child again asks, sir, even if it is bigger, then physics teacher says hari ohm. So what I mean to say, we can certainly, try and make the physics class, a live class, a very, very interesting subject. If any other question anyone has,
there is one question by Vaibhav Joshi. He wants to know some software or the apps that can be used for the assessment of physics.
Ma'am, assessment of physics, it will all depend if you are talking about the new format of the question paper.
Mm-hmm.
Then certainly, there are a number of softwares which are available, but it is only for MCQ. Mm-hmm. And thankfully, the government has switched over, at least in the higher classes. They have switched over from the subjective type or objective type to the MCQs. So there are a number of softwares available. You just Google and you will have at least 50 companies which are providing, this type of. I would not recommend anyone, but then certainly if you Google it, you will have, and most of the schools are using the interactive boards. So any company which is providing the software or the software by which we are teaching on the interactive board, these companies have also extra marks they are providing. Teach Next they are also providing, but I would not recommend anyone. You can Google it, and you will have at least 50 choices.
But I feel it depends on the requirement of your class, the learning slope of the students.
Exactly
What is the requirement.
Exactly. And one more thing, that the question paper, if you talk about class 12th paper, physics paper, there are 3 sections, as we all know. In section A, there are 25 questions, and out of which the child is supposed to attempt 20 questions. In section B, there are 24 questions. Child is supposed to attempt 20 questions. And section C, there are 6 questions, and child is supposed to attempt any 5. So out of 55 questions, the students, they are expected to attempt 45 questions, and time duration is 90 minutes, and maximum marks are 35. And now one physics teacher of my school came to me, "Sir, I have a question. I have a question that why each question is of 0.78 marks, not of 1 mark." He's a new induct in my school, and then I told him that the weightage of marks each question is not decided by number of questions. The duration decides the number of questions, and maximum marks also. Because if they would have made it 1 mark each, it would have been 45, and again the mathematics would have troubled the physics teachers to convert 45 into 35. So that is the reason that each question carries 0.78.
The time is not permitting us. You have taught so many things so swiftly. Quickly, I'll take one question. I think Mr. B. Adulo Kumar from Telangana also asked the same question: is physics dependent on mathematics? And here is Mr. Rajesh Soni, who is asking, Kriti ma'am, will you please share according to you, sir, from which grade or class mathematical expression be included in the teaching of physics?
See, in the teaching of physics, 9th standard onwards, as it is, elementary mathematical equations are coming.
I think, sir, class 6th onwards, when we learn about this S is equal to UT plus half AT square and all these.
Yeah, so, but ma'am, the only problem is with this new NEP. When they will decide about the what do you call it, NCF.
Yes.
So syllabus will also change. Because first they will change in the odd classes and then in the even classes. Right now, the exposure of mathematical equations from 6th onwards, it is too early to give this exposure. At least I would say 8th standard onwards, these mathematical equations should be there. But then again, there are situations where a physics teacher cannot solve a problem without the mathematical equations. That is the limitation with the teaching of physics.
So thank you, sir. Still, I think questions are Shelja Bagel has And thank you, sir, for sharing the points, which sometimes we forget to discuss. Thank you so much, sir. I think the appreciation is pouring in. Still, we are having some question which will be posting you. Time is not permitting us. Thank you so much for accepting our proposal, for joining us and enlightening the teachers. Thank you so much. I request the participants to kindly copy the link of this form which you need to fill in to receive a certificate. So I'll request Priti ma'am to kindly propose the formal vote of thanks. So you can see the chat box is full of appreciation and thank you for you.
Thank you, ma'am. Thank you so much. And
Yes,
thank you, everyone.
Over to Kriti ma'am, please.
Yeah. Good evening, everyone. I, Kriti Kapoor, on behalf of Samurja Educational Society, extend a very hearty vote of thanks to our honorable panelists who blessed us with his presence and took out valuable time from his busy schedule to make physics class vibrant and lively. Sir suggested, first, one should try to introduce a topic in a story-based concept. Secondly, add humor to your class. For definitions, meanings should not be changed, but the language can change. Explain the meaning of each unit and each concept. Relate concepts to our daily life and then make them understand, and finally let them ask as many questions as they want to. I must mention a deep sense of appreciation for all our leaders of Samurja Educational Society for empowering us. I would like to extend a special thanks to Dr. Mukta Mishra ma'am for inspiring us and motivating us to do our best. I extend my big thanks to our Samurja team, especially Ms. Monica Khanduja ma'am, for supporting us in all the events. Thank you, everyone. Namaskar.
Namaskar.
Thank you so much, Kriti ma'am, for making the wonderful videos, coordinating all through with all the participants. Your job is really, really tough, but you are doing it so gracefully. Thank you, Anil sir.
Thank you, Mukta ma'am. And thank you, Monica madam and Kriti ma'am, for the technical support. Thank you so much.